All right, hello. So in this video, we're going to be reviewing how to do these different exponent laws examples. So these are the examples that you have in your notes. You should have gotten this handout to put into your math dictionary. So you can watch this as many times as you need to study, and this is just to really have these examples there with you while you're doing your quizzes or your tests so that you can make sure you are doing the right thing. And the main thing that I want to look at is the difference here between the multiplication rule, so this one here, and the power of a power rule. So I'm going to start with that since that is the most important difference. A lot of you seem to be using the multiplication rule, so this rule over here, when you're doing a power of a power. So a multiplication rule is when you have two sets of brackets. So you will have two brackets here, and you will have two of the same bases. So in this case, we have a to the power of 2 times a to the power of 3. When you have these two a's being multiplied, what you do is you add those exponents. So we're going to do 2 plus 3, and we have our generalized rule over here to remind us that it would be the 2 plus the 3. So our answer here, we're just going to put this in so that we know what we're doing. We are doing a plus, so we're going to have a to the 5, since 2 plus 3 is 5. So now looking at the next example here, this is not a to the 2 times a to the 3. This one is a to the 2 all to the power of 3. So this notation is different. Notice that you only have one set of brackets here. You don't have two things being multiplied. You have a to the power of 2 being multiplied by itself 3 times. That's what that 3 means. So this, what's really happening here is a to the 2 times a to the 2 times a to the 2. This is a multiplication. So here we would add those 2's up, which is the same thing as saying I have 3 2's. I have 2 times 3. So when you have this, and I'm going to take this away because this is not what you should be writing. When you have this situation of a exponent raised to another exponent, then here you should be multiplying these two numbers. So this is a multiplication. You're going to have a to the power of 2 times 3. So that would be a to the 6. So that is the main difference here. So we'll just finish up the power of a power examples. So the second example I put in here so that you can see what happens when there is a coefficient. So when there's a number at the front. So this 3 has to get applied here and here. So when we expand this out, this is 2 to the power of 3 and a to the 3 to the power of 3. 2 to the power of 3 we know to be a number. This you can calculate. This is 2 times 2 times 2, or you can use 2 to the power of 3 button on your calculator. So that would give you 8. Here, my a to the 3 to the power of 3, we know we need to do a multiplication there. So that's going to become a to the power of 3 times 3, which would be 9. So your final answer is this over here. It's 8a to the power of 9. So now we're going to backtrack and look at these divisions. So when you have divisions, instead of adding your exponents, you would be subtracting your exponents. So here, 4 minus 2. So this would be a minus. You would be left with a to the power of 2. a division can also be written like this as a fraction. And I find that the fractions are a little bit more visual because you can see I have 6 of them on top, I have 2 of them on the bottom, and you can kind of visualize that cancellation a bit better, but it's the same thing here that you are doing 6 minus 2, and you would get a to the 4 in this example. Okay, so our next one, power of a product. So power of a product is always used along with power of a power. What power of a product is telling you is that just because you have 3 different pieces within your brackets, that exponent on the outside has to get applied to each of them. So that's what it's telling you. It's saying that it has to go here and here and here. It doesn't go to just one of them, has to get distributed to all 3 of them. So that's what power of a product tells you, that you're going to have 3 to the 3, you're going to have a squared to the 3, and b to the 3. And then you would have to finish that up. So here we're going to have to do 3 to the power of 3. So that's 3 times 3 times 3 will give you 27. And then over here, we're going to have to multiply again those exponents because that is a power of a power. So we're going to get a to the 6 and the b to the 3 stays the same. Okay, so that is power of a product. Power of a fraction is an extension of power of a product. So power of a product, we know that for the top, let me change those colors, go back to green. So we know for the top, this is not a surprise. And then power of a fraction is telling you that exponent 4 also needs to be distributed to every piece that is on the bottom of the fraction line. So it's not just on the top, it has to go to every single piece within those brackets. So they all need to get that power of 4. So you can write out the intermediate step here. You can put your 2 to the power of 4, a to the power of 4 over 3 to the power of 4, b squared all to the power of 4. So again, this 2 to the power of 4, that's going to become a number, so you have to evaluate that. Same thing with the 3 to the power of 4. So this is 2 times 2 times 2 times 2, which I believe is 64. No, it's not 64. It would be 16. 8 times 2, right? 2 times 2. I'm just using my calculator. Yeah, it is 16. A to the 4, that doesn't change. 3 to the 4 is 81. And then this b squared all to the power of 4, remember that that is a power of a power, so those need to get multiplied. So that would become b to the power of 8. And yeah, and then that would be your answer. Right over here. Okay, next one. So this is just a whole complicated mess within these brackets, but this entire bracket is the base of this exponent 0. And our rule here is that anything, this a, really means anything, any number raised to a power of 0 will give you 1. So as complicated as this expression is, because all of it is raised to an exponent 0, the answer is just 1. Next one is our negative exponent. So here we have a negative exponent. We know that we are not allowed to leave final answers as negative exponents, so the negative exponents need to move. Here, what we do is remember that every number under the sun has a denominator of 1. We don't write it because it's redundant. Anything divided by 1 is itself, but that 1 is there. It's not going anywhere. So what we do is, since this b here has an exponent of -2, we don't want to leave it there because we don't like that negative. So that entire thing of b to the -2, we're going to send it down to the denominator. And when we do that, the sign of the exponent changes. So we can't just send it down and have everything stay the same, right? Because we're changing something, we're changing its place, we have to change something to compensate for that change. So what happens is we get 3a, that stays the same, and now our b is to the power of +2. And the 2 is now positive because I've moved the location of the b to the -2. Because I have moved its location, I have to change that exponent to a positive. So next, this example here, we have -3a to the -2. This is confusing because you see this negative and say, oh, I can't have negatives in my answer. But be careful, we can't have negative exponents in our answers. This -3 is a negative coefficient. It's not a negative exponent. So this -3 actually doesn't bother us at all. The only negative here that bothers us is this exponent -2. So this is the only thing that's going to need to move. So remember, we have our fraction line, we have our invisible denominator of 1, that a to the power of -2, that's going to move down to the denominator where it won't bother us anymore. The -3 is going to stay on top. It does not need to move. And because we're moving that a, its exponent is going to become positive when we move it down to the denominator. Okay, so that is it for negative exponents. On to our fractional exponents. So we haven't been dealing very much with these. I don't expect that you'll see very much of them for the rest of the year, but it's still good to keep this in mind. So when you have a fractional exponent, this gets changed to a radical. Oops, sorry about that. So this will get changed to a radical. So as soon as you see a fractional exponent, you put that radical sign. The denominator of your fractional exponent, that's going to go right in here. And then the rest of it will go with your a. So you're going to have a to the 3. So let's just color code this. So our denominator goes here, and our numerator goes here. And our base goes here. And I'm emphasizing the base because in this next example, the base is more than just one variable. It's this entire thing within the brackets. So that's something to remember. Since we have a fractional exponent, I'm going to set that up with my radical sign. I'm going to take my denominator of 5, I'm going to put that in over here. So that's my 5. I'm going to take my numerator, I'm going to put that in over here. That's my 3. And now I need to take my my base, and I'm changing that because I want to highlight everything. So this entire thing is my base, which means the entire thing with the brackets need to go in there. Okay, so that would be your answer for a fractional exponent. Again, I don't want you to worry too much about fractional exponents. What I really think everyone needs to focus on is the difference here between that multiplication rule and the power of a power rule. So I think if I'm going to emphasize any of these, and you know what, even a little bit with the negative exponent rules, I think that quite a few of you need some practice there. So if I'm going to put stars on any of these, it would be, let's get a nice bright yellow in here. I'm going to say this one, multiplication rule, power of a power rule, and negative exponent rule. So these definitely everyone needs to review these. All right, so that is it for me. Bye.